Our next speaker, I actually met on a bus going to an aquarium, believe it or not. He told me about the book he's just released. This is a couple years back, so this is well before. And I'd been hearing about this thing called the semantic web, for some time, and so kind of understood. Because I never really understood why we should be getting so excited about it. And I must say that in that bus ride, I kind of learned more about the semantic web and why we should be excited about it than certainly at any time before and any time since, actually. He was Amazon.com's, one of the Amazon.com's very first Amazon.com originated bestsellers with his book, Secrets of Successful Websites. He has recently published a book called Pull. And I'd like to welcome David Siegel to our stage to tell us a bit more about it. Thanks, David.
Thank you, Herb. Thank you. Thank you very much, Herb. It's great to go after Jer because today I'm going to challenge you to rethink your relationship to information. And I'm going to do that by asking you to imagine yourself working at your desk about 10 years ago in the year 2000. What were you doing? You were staring at your screen, wiggling your mouse. You were using a word processor, spreadsheet, surfing the web, sending emails, right? Now imagine yourself last week in 2010 working at your desk. What were you doing? About the same stuff. Yes? More or less. Maybe a little faster, maybe with a little more information, but relatively not that much change in the last 10 years. So here's my question. In 2020, 10 years from now, will there be much more change in the next 10 years than we've had in the last 10 years? Do you think? I'm seeing if anybody's alive. Yeah. Now that's a pretty easy question. So who's willing to say that in the next 10 years, we'll see more change than we've had maybe in the last 20 or 30 years combined? Lots of change coming in the next 10 years. Anybody? Anybody? Oh, I see about 40%. Very good. All right. Now, in the next 10 years, we humans will face unprecedented economic challenges. And all of these crises have one thing in common. Oops, wrong talk. This is the story of information. Originally, human beings exchanged information face-to-face, verbally. Then, around 12,000 years ago, someone started writing things down on whatever medium they could grab for other people to read later. So as events unfolded in the real world, we wrote things down, and other people were able to learn later what had happened. Sometimes the time lag between what we learned and when others learned it was measured in decades. And as the Industrial Revolution heated up, we put long hours into writing things down, writing down what happened in the real world. We kept our information in books and binders, on shelves and in boxes, until 1898, when this man, Edwin Siebels, invented the vertical filing cabinet, which let us store our information upright, unfolded, organized by folders, and with that, the information revolution took off. We started creating and storing more and more documents, and the knowledge worker arrived to help us organize everything. All our information here shown by the red line. Watch it grow. We built temples to honor and preserve our documents. Finding them was a little more difficult. For the last 30 years, we've been digitizing our documents, digitizing our information, storing it in data centers, and putting it online to share with others. Now, we now have almost 2 billion web users and almost 5 billion mobile subscribers. We have now digitized over 500 exabytes of data. 500 exabytes, that's a big number. That's a 5 followed by how many zeros? Anybody? Anybody at all? How many zeros? 5 followed by, say, 20? Oh, good, good. Tech-savvy audience here. Very good. Okay. Now, what is all that information? We've digitized a lot of information. What is all the information online? Well, less than 1% of it is fiction. The rest, more than 99%, is about us. Information is what markets are made of. Information is what we use to make our travel plans. It's how we campaign and vote and change our government. It's about groups and individuals, grand plans and accomplishments. It's about learning from our mistakes. And it's about seizing the moment and doing what needs to be done out here on our side of the screen. People ask me, how do you give a good talk? In just 2 words, elephant polo. Now, where is all this information going? In 5 years, we will have 20 times more information than we have today. In 10 years, we will have 50 times more information than we have today, and we will have 50 billion devices connected to each other. And the problem with information is that we are still pushing information, and we are pushing the wrong kind of information. We are moving files and folders manually. We write on e-paper, we write electronic checks, and we send electronic mail from our desktops, sometimes using a carbon copy. All of this was invented in the 19th century. We made it digital, we got good at it, and it stopped working a long time ago. Here's another example. Ask Google, what's the temperature in Venice? Google does not know the answer. Google gives you a list of sites that have the keywords, and it's up to you to manually go and interrogate those sites and decide if you can find the answer there. If you're looking for a job, it's pretty sophisticated. You compose your resume in Microsoft Word and deposit it on maybe a dozen different websites. Each website has its own login, its own forms to fill out, and keeps your resume without knowing really anything about you. You can't turn this off either because they share information with hundreds of other sites. Once you get a job offer, you will continue to get offers for months and months afterwards. We have invested trillions of dollars in recreating our old ways of working. We can't even share electronic invoices today because they're in different native formats in all the different systems. Search engines can now see over 1 trillion web pages, but they don't know what information is on those web pages. We have created a digital Tower of Babel, where all our information is in different languages, in hundreds of thousands of different databases. And that causes us to re-find and research for our information, re-enter our information more than we might think. Think of all the times you have to re-type in new keywords to maybe find what you're looking for online. Think of all the time you have to translate your contacts into a new program. So the solution to the scale problem is the shift from pushing information to pulling it. It's easy to understand pull. It's the opposite of push. In the old days of TV shows, a TV show was broadcast at the time that was convenient mostly for the advertisers. They were broadcast at a fixed time, and if you weren't home on your couch to watch your favorite show, you missed it. But consumers now have technology that reverses that relationship. Now we expect to watch TV shows on our terms, when we want, where we want, on any device we want. Google's announcement last week is another step in this direction. Soon, we will pull everything to us on our terms using something I call the personal data locker. Now, your personal data locker will hold all your personal information from your computer and what's spread around the digital universe right now. The applications and services will live elsewhere. To work or play, we won't need Macintosh or Windows operating systems. We'll just need cheap screens of any size that can see the net. Once we have personal data lockers, we'll give a doctor access to our health records on our terms. We'll do the same thing with our personal information for marketers. We'll be able to apply for a home loan with one click. We'll replace our smartphones with dumb phones. Dumb phones are fantastic. if I lose my dumb phone or it breaks, I just borrow yours, log in, and your phone becomes my phone. Dumb phones have infinite storage capacity and are infinitely more powerful than smartphones. Thank you. You'll be able to use that in about 5 years from now. We'll also have shared workspaces rather than sending files back and forth. So you can see how different things are going to be. Now, pull is the answer to the scalability problem. And the way we will do it, the way we will set up our information, will require the principles of the semantic web. I'm just going to show you a few of those principles and give you a quick tour of how things will be. When you hear the term semantic web, it's not a lot of fancy artificial intelligence or gobbledygook. Just substitute the word unambiguous for the word semantic. Every time you ever hear the word semantic, substitute the word unambiguous. Unambiguous information means the same thing to any person or program that encounters it. It means exactly the same thing to all people and software. So as an example, here's an answer engine called Wolfram Alpha. Wolfram Alpha does not see as much of the web as Google does. But what it knows very well. They employ experts to put data into formats that are unambiguous, so it can give you an answer like this. For example, if I type in, what's the temperature in Venice, it first disambiguates the question. Any good answer engine first makes sure it knows what you're asking. So it disambiguous asks if you mean Venice, Italy, or other places possibly called Venice. Then it just shows me the answer, tells me what temperature it is in Venice right now. And then it asks me if I want to choose a different system of measurement like metric. Why? Because only 3 countries in the entire world haven't officially adopted the metric system. And they are? United States, Burma, and Liberia. Okay. So we might want to change to metric. Now, then it shows me a raft of data, historical data of temperature, and lets me look at a 10-day forecast. It also shows highs and lows for this day throughout the period, and then it shows the source of the information. Not only the source that it's chosen, but 2 other potential sources for temperature data, here sorted by elevation, which is what you'd want in this context. Okay? So that's how an answer engine works. The second thing is it will be findable. Information that's findable has an authoritative source, and it has a unique name that allows it to be found no matter where it is. So let's try another Google test. Here I've typed in global GDP. Now Google has a new program to allow site owners to identify key data inside of their sites, and that surfaces the information right here, right in the search results. Shows us $61 trillion source World Bank. And if you want to click through, you can see the World Bank website. Now, Wolfram Alpha does it a little differently. Wolfram Alpha approach. Wolfram Alpha queries the central banks of 231 countries and shows us the sum in real time. A little bit different. You can then go on and slice and dice this data, look at the historical information. It breaks it down by country and so forth. So the data is findable because Wolfram Alpha identifies the GDP figures coming out of each central bank as a permanent, reliable data feed. In the semantic web, there are no copies or translations. We won't even need what Jer talked about, the bridges that Jer talked about as much, because everything will flow like water, as I'll show you. Unique names for things make them findable, just without knowing their locations. It's the unique names that are important. On average, knowledge workers, and that's probably you, spend 53% of their time looking for information. Not creating or working with information, not storing it, not copying it, just looking for information. When we make our information findable, we will spend a lot more time able to work on projects and solve problems. Semantic information is interoperable. Interoperable means it should be in common formats, so those APIs more or less disappear. Here's an example. Suppose you're a shipper. You ship, say, 50 or more packages a day. Your company ships a lot of packages. You are a shipper. That means in the United States, you have your choice of 3 carriers to work with: UPS, Postal Service, and FedEx. Now, each of these companies plays the same game. They do exactly the same thing with their own proprietary data formats, so that to work with any of these companies, you have to do custom integration costing hundreds of thousands, even millions of dollars. The carriers love this. This is a profit center for them. They can do IT work for you and charge you a lot of money, and it ensures vendor lock-in if it's hard to work with their competitors. So this kind of information is common. This kind of information barrier is common in many industries. It does not have to be that way. Instead, we could replace all the proprietary formats with a new universal tracking number, a new set of codes, and new messaging standards. And initially, everyone translates to the new set of standards that are governed by not a single company, but by a nonprofit consortium. In the second phase, all the systems make these new formats native, getting rid of the translation and letting the data flow like water from one company to another. Now, when you move the information, you move the package. Here's an example. Who has a birthday today? Who's got a birthday? Do you have a birthday today? Far out. Okay, what's your name? I'm sorry? Fernanda. F-E-R-N-A-N-D-A. Okay. I'm going to send you a package, Fernanda. It's a book. It might be one I've recently written. And I want you to have a copy of my book for your birthday. And now that you can pull the book to you, I don't care which carrier I give it to. I just give it to any random carrier, drop it into the mail stream, and you, Fernanda, you pull that book to you. Okay? Fernanda, even if you move, even if you get up and move, even if you are on the run and you're going somewhere, even if you can't, it's hard for you to be found, you go somewhere else, that package, you can still pull that package to you, Fernanda, right? Because you know where you're going, you set your schedule, and there it is. Thank you. That is the first thing you've pulled to you, and each carrier along the way doesn't have to know where it's going, just has to get you the next step closer. Okay, you're in charge of the final destination. You could even reroute it to someone else as it's midstream. That's the power. Do you see the power, how the relationship changes? Because I didn't put your address, I put your unique identifier. And that changes the relationship from the customer being the supplicant in this business to the customer being in charge. Okay? Now, that ought to save a little bit of money. In the United States, a system like this would pay for itself in months. We in the United States Postal Service returns over 5 billion pieces of mail a year because of incorrect addresses. So just making that shift to a unique identifier and letting you pull will save hundreds of billions of dollars, actually. Now, information should be modular and reusable. I know this sounds crazy. I know this isn't done, but just hang with me for a minute. There are a few people doing modular reusable information, and they're using a language called XBRL for financial reporting. The data in this annual report is modular. It uses a common framework that never duplicates any information. Only the changes go out every quarter when the company files a quarterly report. If the company makes a change to any number, that change ripples through the ecosystem automatically. Every number in this financial report has a precise, unambiguous definition that comes from an online resource, and that's called a taxonomy. It's a big dictionary that defines everything very precisely. It's a public-private enterprise that maintains this resource for everyone to use. Every company in the United States filing reports with the government now uses it. In fact, XBRL is now used in more than 90 countries and is required by many governments, including the United States SEC, for filing reports. Now, information will have to be pullable. That makes sense. We're used to sports scores and stock prices kind of at our fingertips coming all the time. Soon, there will be ridiculous amounts of information, huge amounts of information will be available at our fingertips. We don't want to have to build bridges to each one of those. We want them to just work automatically. So an example is Europe's NoTube project, which combines videos with information about videos from hundreds of resources. So you can create a personalized, context-aware, device-independent television experience for yourself. XBRL, as I mentioned, is not just for financial reporting anymore. It's more than 10 years old, and it's now creating a web of interconnected financial data for all kinds of things, both in the private sector and with government. In the semantic web, the data is more important than the applications. We'll be able to write software just in a few hours or days and let the data make it better over time. This kind of adaptive software is smarter today than it was yesterday because the data continues to make it smarter. It's always learning from the information it processes. So there will be a lot less recoding and a lot more data flow. If you think of data as water, in fact, we can see ourselves hauling our own water back and forth, managing the mechanics of carrying water, mixing dirty water with fresh, spreading viruses, and trying to drink from the bucket. In the semantic web, we invest in installing indoor plumbing so that the water we're looking for is always on tap, and we can work more on solving problems than managing information. So now that we've adopted these principles, let's see what we can do with it. Here are two examples of semantic search. I'm just doing this from a site called BlueNile.com, just from screenshots, but you can do it easily on your own anytime. So feel free, but not while I'm talking. I'm going to look for a diamond. I'm going to look for a solitaire for an engagement ring. And in this database, there are right now yesterday, 36,228 round diamonds. And so I'll just set a few parameters here. First, I'll choose the carat weight, and I'll go for something like around 1.4, plus or minus 1.4 carats, and that narrows it down right away. So we can see that we are now down to 147 diamonds. This is real-time inventory. We'll now check the cut and the color and make an ideal cut and a fairly colorless diamond that we're looking for. Now we're down to 25. And move the clarity, not flawless because that's a bit too expensive, but into the VVS2, VVS1 range. You can see the diamonds now sorted by clarity. You can see them then secondarily by weight, and that pretty much gives you the price on the right side. Each diamond has its own digital birth certificate that specifies that diamond unambiguously from all other diamonds. And if you click on one of these diamonds, you'll actually take it out of inventory and it won't show up on anybody else's search. You can actually further refine this search by various geometry parameters and other things. So you can slice and dice this information because it's comparable. Imagine doing that over the entire web. Imagine a web of diamond data where the search engines let you semantically search for all diamonds in real time, anytime. And as soon as one comes on the market, it appears, and as soon as someone takes it, it's off the list. You can slice all that and dice all that information because we are always comparing apples to apples in the semantic web. Something that a speaker talked about, they did a demo earlier this morning. It's a very rare thing on today's web, on today's internet, to be able to compare apples to apples. It's something we hardly ever do. We have to manage our own data to do it. And that's why this program they showed earlier is very helpful. Now imagine that we are able to do these kinds of comparisons and this kind of semantic search on all products, maybe even all services web-wide, instead of just within a single site or having to hand manipulate information between sites. Here's another one. Let's go forward 10 years. Your resume is now in your personal data locker. It's modular. You never have to touch anything unless it changes. You have your personal contact information, background, your skills, education, awards, job descriptions, company names. All of this is specified unambiguously and lives in one place online. Now, to look for a job, you specify the kind of job you're looking for using a controlled vocabulary, and that turns it into data, which isn't available on the web yet because you've said, you're not available. But change that one field to actively looking, one click, and you're now exposed to the web without necessarily you see, we're withholding your personal name and contact information, but you can now show up on the screens in real time of thousands of potential employers. You make that one change and you go to sleep. You wake up the next morning and what do you have? Offers. Offers coming in that match your criteria. The computers, the software has been able to do the match rather than all of us doing it by hand. It may not get you hired, but it will get you the interview you're probably looking for. Because there are no copies, all the data is always live. When you find a job, you click you go back to unavailable, and immediately you disappear from the screens of thousands of possible recruiters. So that's semantic search. Now, the semantic web has become a marketing buzzword and is pretty confusing to a lot of people. So I'm going to give you the semantic web acid test to apply to see if any project can scale up. The old way of doing things is that we pushed unstructured information onto a website or into a database. That's probably your website. Here are some companies that have gotten very good at this. They are pushing unstructured data through a single API or a single database or website. The new way to do it is to make your information pullable, make it unambiguous, and put it on the open web where it can be seen by everybody, search engines included. Here are a few projects that are on the leading edge of passing the semantic web acid test. There are more, and Joy Ito, one of our speakers here, is a big proponent of open data. That's a big part of it. So spend some time with him and you'll learn more about the semantic web acid test. Now the journey ahead is going to be interesting. We're going to make a huge change from push to pull. We don't need any new technology to do this. There isn't anything particularly fancy about it. It's a change of attitude. So in push, we are guessing. We are predicting. In the world of pull, we react and provide. The supply chain becomes a pull chain. Marketers find a way to fit into your life without interrupting, actually adding value instead. Now look at these last two items. We're going to shift from companies doing customer relationship management to customers doing vendor relationship management. That might be a different world. Somebody else might be driving than has been driving for the last 100 years of business. In the world of pull, customers can move their entire account to your competitors in seconds with the click of one button. That button, move my account to or from your competitor, will be on every screen of every application and every website, thanks to the work of people working in data portability right now. I hope you can see that the tables are about to turn 180 degrees. 12,000 years of analog communication are now coming to a close. We've spent the last 30 years digitizing information, and we have about 10 years more to go, at which point it will be appropriate to rename this conference. We've spent the last 15 years putting information online, and we have much more of that to go. We are going to put on much, much more information online than you can possibly imagine. But it's now time to take the next step, to go beyond thinking digital. We're going to start putting our most important corporate and government information on a semantic footing, allowing people to pull information as easily as they turn on the tap. This overhaul of our information infrastructure will take the next 30 years, and we call it the semantic wave. What comes after that? After we've set up the plumbing that makes pull possible, is that our processes and products will generate semantic information automatically, like a very few products do today. But that will constitute the bulk of that 20 times and 50 times more information that I spoke about earlier. A small but good example of automatic creation of unambiguous data is the way we go bowling today. You go bowling, You roll the ball down the lane, and the scoring is done automatically by the machine. So it's already unambiguous, and when we set up the semantic web, our bowling scores will go where? Into our personal data lockers, and so will every other piece of information. Your personal data locker is going to have every bit of your DNA code, every test you've ever had, everything you can imagine that you generate automatically in your life will go into your personal data locker under your control. Now, I estimate that out of that $61 trillion economy worldwide, something around $15 trillion is generated by knowledge workers. I don't have time to derive this, but I estimate that if we can invest in semantic technology and put ourselves on a pull semantic footing, we will save $7 trillion a year if we just install indoor plumbing for our information. $7 trillion a year. That's another big number. How many zeros in 7 trillion? It's a 7 followed by how many? 9. No, it's actually 12. Where do you get your information? I don't know. Okay, well, 12 zeros. It's a big number. Now, let's come back to the question I asked at the very beginning. How different will 2020 be from today's world? How different will your work life be from today? Certainly, we'll be staring at screens and wiggling our mice, or wiggling our eyeballs, or wiggling our brain stems, or I don't know, we'll be wiggling something. But you'll be getting 50 times more emails and dealing with 50 times more information than you have today. And you're either going to spend 53% of your time looking for information, or 93% of your time looking for information, or maybe 13% of your time looking for information, depending on what you did after my talk today. So it's time to get started. We have almost no time to lose. The scale issue is starting to dwarf everything else. We can't keep building bridges for data. We have to put it on a semantic footing. Practically everything we've done to this point to make us successful is starting to work against us. We are going to have to adopt new strategies and try some things that haven't been proven. Some may not work, but in many cases, I think there's a bigger risk to maintaining our existing systems, which is where we spend 80% of our IT budgets today. Now look back in your own organizations. I've challenged you. I want you to look back right now and tell me whether you think your organization has gotten very good at making old processes and old paperwork methods digital. Not very many. Almost none. Wow, that blows my next slide. That's great. Well, I wonder what you have made digital in that case. I want you to understand that we are going to have about 2 billion more people on the planet over the next 30 years. We are going to add 2 billion more people in the next 30 years. Almost all of those people will live in cities. Almost all of those new people will be connected to the digital world. We're on this spaceship together. We humans are now responsible for most life on the planet. And our planet now has a command and control system that was designed and cobbled together over the last 30 years and is now way past its breaking point, even as the pace of life speeds up tremendously. If we can change the way we think, if we can set up our most important information to be pulled, it will have a huge effect out here on our companies, our economies, and our lives. So if you tweet one thing from my talk today, I can do it in under 140 characters. Tweet this. What we do online and how we do it matters.